All right, so let's get started. This is from your 7 packet. So, how tall do you need to be in order to play in the NBA? Well, it depends on what position you play. So, in this lesson, we'll try to find the average height for all power forwards by taking a random sample of 5 power forwards. If you don't know what a power forward is, you can look it up. Um, so let's do this. So, what is the population? So, your population are going to be all NBA power forwards. And what is the sample? The sample is the 5 NBA power forward selected. Okay, and they tell us that right there. Okay. Um, so I'm gonna post the handout that has the height of all 115 power forwards. I'm gonna describe the distribution of the height, so it's gonna be approximately normal. And the mean is gonna be 80.087, and the standard deviation is gonna be 1.519. I'm gonna show that to you in just a second and pull it up. Okay, so here is the list. And so we're looking at this graph. And then here is the standard deviation. Here's the mean. So that's where I got those numbers from. Sorry, I should probably have given that to you, but here they are. Okay. All right, so back to our documents. Okay, so take a random sample of 5 power forwards, record their heights, and find the mean of the sample. Do that 3 times. So you can do this on your own, or since, I have stopped trusting y'all with samples. Here's that one with our mean of 80.4. And on the next one, we got 81, 80, 82, 78, and 83. And that's going to have a mean of 80.8. And the last one's going to have 80, 81, 81, 80, and 79. And that's going to have a mean of 80.2. Now, we're going to take all of these means and we're going to add them to a dot plot. Okay, so we're going to add all of those to a dot plot. Right here, we're going to have 1, and 2 right here, 3, 1, 1, 2, 3, 4, 5. Okay. All right, and here are the rest of the dots. Again, doesn't have to be super perfect. This would just be like a sample of all of the means, sample means that you took. All right, so we're going to describe the distribution. This is approximately normal. Like we have like a peak and then it kind of like levels off. Okay, so approximately normal. Approximately normal. All right, and the mean estimated, it's all about 80. Okay, it's not super perfect. This is what we're gonna call mu sub x bar, which is just a mean. This is gonna be that 80.087. That's what we found earlier. Okay. Our standard deviation estimated is about 1. Okay, majority of our data falls within 1 unit. Okay, and this is approximately normal because the population distribution is approximately normal. Remember, the population distribution is talking about all of the 115 power forwards from earlier. All right, so we're going to use a normal distribution to find the probability of taking a random sample of 5 power forwards and getting a sample mean less than 79 inches. Okay, so we're going to find the z-score, and our estimate is here, 79. Our mean is 80.087. And we're going to divide it by the standard deviation that we found by taking, I'm giving you that information yet, by taking the standard deviation of x bar is sigma divided by the square root of n. So we've got 1.519 divided by the square root of n, which was square root of 5. Excuse me. And that gives me 0.67. So our standard deviation is going to be 0.67. Okay. So again, this number came from up at the top with 115. That's our population. Excuse me. And so that's going to give me negative 1.62. So our area, once you go into the z-squared table, is going to be 0.0526. Remember, when you talk about a normal distribution, you got to draw the curve. And we're talking about 79 and below. And our mean is 80.087. Okay, this is the sampling distribution of X bar. Okay, when you're done, flip it. Almost done. All right, so we talked about sampling distribution. And we talked about the shape. This is going to be approximately normal. Okay, and the center is going to be mu sub x, which is just mu. The variability is sigma sub x bar, which is sigma divided by square root of n. Make sure that you check the 10% rule on this one so that you can do sampling if sampling without replacement is happening. We talked about the curve and we draw it, and that's your x bar. Your mu is in the middle. And then we talked about z-score, and we said x bar minus mu divided by the standard deviation divided by the square root of n. Okay, I would try A, B, and C, and I'm going to put the answers on here in just a second. All right, so for part A, you should have gotten the Z is 1.23, and so your area is 0.1093. Okay, remember we want to draw the curve. We're saying more than 25, and our mean was 18.5. Okay, for B, what's the mean and the standard deviation? The mean is mu sub x bar, which is mu, which is 18.5. The standard deviation is going to be sigma divided by the square root of n, which is 5.3 divided by the square root of 10, which is 1.676. Remember, you got to check your 10%. 10%. So 10 is less than 10% of the millions of genes. Millions of genes. Okay.